Hello, everybody. Welcome to another Bobcat Cam live event. My name is Andrew. I'll be the host. And we're going to be taking a look at the Rhino V3 plugin for Rhino. First, let's take a look at how you enable the plugin. So once you have the software installed, you should have your Bobcam tab up here. But if you don't, you'll need to go to your plugins and go in and make sure that it's enabled. Mine is already enabled here. And once you have it enabled, you'll have your drop-down menu. You can do Show Bobcat Cam, which will show it up here on the side once it loads. So we're just bringing our cam tree right into the Rhino environment. So we have our cam tree, our new operations tab. So anybody that's on V2 or V1 Rhino plugin is not going to have this. This is with the V3, as well as the tool tree, and then your posting window. At the top, you'll have your data entry manager, your cam manager, and your Bob Art manager for your different tabs. So let's go ahead and load in a part file. I'm just going to drag and drop one to the screen here, and I'm actually going to use the perspective view and just double click on that. And I just have a wireframe geometry here. Looks like 2 polylines. I'm going to go ahead and go to my cam manager, right click on cam defaults, and I'm going to go to new job. Now you also do have new job here under the cam tree, as well as if you have the Bobcam tab shown, you'll have all your settings and everything else up here. And actually, let's veer from the geometry for a second, take a look at our settings. So current settings, you can set your default machine, the machine definition, what post processor is being used on that machine. And if you're using a multi-axis machine, we'll actually set the multi-axis posting stuff for you. Machine parameters, though, you do have a lot of different machines in here. I'm just going to go ahead with a basic Haas 3-axis as my default. Now, with that saved as my default, one of the new options that we added in V3 is the new custom coolant options. So if you're using through tool coolant, you can now add that into your post by adding into the blocks here. If you do need help with that, just contact our support department and we'll help you get along. All right, so the other settings we have our cutting conditions. Now this mostly is going to be based off the drilling. We add 50 thousandths to any drill depths that you do. And if you're doing pecking with that drill, we do 50% of the tool diameter per peck. These are just the defaults. You can change them per operation. That's really the main settings that you're going to manipulate within the cutting conditions. So we're just going to move on from there. You're also going to have your dynamic machining strategies, which we can talk about at another time probably. Tool library. This is going to be for all of the tools. This is your default. So this is going to be your drills, your mills, your turning tools, your generic, which is your probe, laser plasma, and water jet. Today we're looking at 2-axis mills, so we're not going to look at most of those. You have your tool holders and adapters for those of you on the live tool lathe mill turn package, as well as our thread library. Now the thread library applies for both threading and thread mills. So if you do either one of those, you want to make sure that you have your threads defined fully. You know, if I go in here, for example, I'm just going to grab the 1" 8. So when you're defining a thread, you're giving us the major diameter, minor diameter, and the pitch, and the thread angle. The only big thing here is the hole sizes. Whether you're doing a cutting tap or a rolling tap or form tap, it's going to change the drill size. Other than that, the tapping is exactly the same, the can cycle should be the same, and they shouldn't really matter too much. But we do use this definition for thread milling as well. So if you do a lot of thread milling and your threads are not defined in here, you can make your life a little bit easier by defining it in the thread list. You also have your material library if you want to set the automatic speeds and feeds per material, and your knowledge base, which we're going to look at the knowledge base here on another file since we're going to take a look at some of the hole recognition, as well as your simulation, exit and start, your NC editor, and you could add properties to holes which go along with the knowledge base. So I'm going to go ahead and start my new job. So right away I can see I have my different job types, we're going to be looking at milling. And it's like my Haas 3-axis mill is my default machine. So I'm going to go ahead and click OK. Now that adds the milling job to my cam tree. Under milling job, I have my default settings. You can save different custom template settings. So if you're doing a lot of different types of materials, say you're going from aluminum and stainless, and you just want to save settings per different type of operations, you can. Then under that, we have our machine and the post processor for that machine. So you can have the BC3X mill and you can use a machine for a different post. The post processor is really what's formatting the toolpath data to fit to your machine. Our milling tools, we can load up a tool crib. If we have specific tools that we need to load in, we can add them from here. And in the new version, V3, version 35 and V10, you can disable the automatic tool numbering. So if any of you guys have ever used any of our other versions, you can now disable the automatic tool numbering and you're in full control of what tool numbers you're going to have. That'll actually come up here once we start looking at the tool paths. Under that, we have our workpiece, which I don't actually have one. I need to have a solid model to define a workpiece. And it's really not going to help us too much when we're looking at 2-axis toolpaths. Then we got our stock. Now we do need to define our stock model for the job. So I'm going to right-click on stock and go to Stock Wizard. So that's going to automatically define that stock based on the geometry I have on the screen. So it's a little under 6 inches. I'm going to just increase that just a little bit. I'll make it 6 by 6, and I'll leave it the 1-inch thickness. So I'll go ahead and hit forward. Now the next page, we have our machine setup. One of the big things that I struggled with when I first started using the Rhino plugin, because I'm not as comfortable with Rhino, at least not anymore, is that if you do not have your snap on for end and you're trying to snap to the end of a section, you're not going to be able to pick that point. So keep that in mind. Your snaps are going to matter in this particular scenario of how you're actually setting that G54 0. But I'm setting it in the upper left-hand corner. I'm going to go ahead and go down to the bottom and hit OK. So now my job is set, but my stock is pretty thick. It's a little dark and hard to see through. So I'm going to right-click stock and go to transparency. And remember, this is the same cam tree for all 3 of our products. So if you guys are in V35, V10, any of our versions, the stock transparency can be set and saved as a default. So if you didn't know about that, you can set that under your stock. Then underneath our stock, actually, if I expand stock, we have the material we're using. So if you're using the automatic speeds and feeds, you can set the material you're cutting. As long as your tool material matches what you're actually using, you'll get in the ballpark if you've modified the speeds and feeds. They're just generic values in there, so you do want to go ahead and adjust those if you need. So I'm going to right-click on Machine Setup. This is our G54 that we've already set, and I can see that it's right there. And I'm going to come up to Mill Facing. I'm going to start it with just a facing operation. Now, the facing operation is the only operation you do not need to pick geometry. So it even gives us a little description here. Geometry selection is not required by default. This feature will automatically utilize the stock in the workpiece to calculate the facing area. If you wish to choose your own geometry or have different stock model, please choose the Select Geometry button below. We're just going to hit Next. Now, the default depth for facing is going to default to 100 thousandths. For me, I usually set that to 0. When I was running routers, I would set my G54 based off of that 0. I would just lower the G54. On mills, if I touch off the top of my block and I know I'm going to face off 30 thou to start, I just go in and adjust my G54 30 thousandths less. But I usually face off at 0, so any drilling and other operations I have are relative to the Z0 plane. Now I can see my rectangular facing area here. We're going to go ahead and hit Next. And then we only have the one operation. So I'm just doing a facing. I'll go ahead and hit Next again. Now our posting page, we don't need to do anything here. We're going to go with G54, and we're not using a rotary. All right, so our tool. I'm just going to go ahead and type out 2-inch. Now, just like previous versions in any of the previous versions of BobCAD for SolidWorks or the BobCAD standalone product, you'll have the system tool on. You'll see diameter and corner radius are the only things you can adjust. But now in 35, V3, and V10, if you uncheck System Tool, nothing can be changed. Because in previous versions, most people didn't understand that if you modified the tool when unchecking that System Tool, you're actually defining a new tool. We would get calls of people saying that their tool numbers are being changed. Well, they were defining different tools by unchecking that box and then changing values. So we've made it more clear now that if you're modifying the tool, you uncheck System Tool, click this drop-down menu, and then you're modifying that specific tool. So if I need to change this to an insert cutter, if I'm using the automatic speeds and feeds, or if I need to change the number of flutes, I'm changing it for that specific tool, and it's not going to change the number on you. Now I'm going to go ahead and hit next. I'm just going to go with the 2-inch face mill. Then you have some patterns here. Now, typically I would use zigzag. That's fairly common. I'm going to go ahead and use adaptive this time. Now, really, anytime you see adaptive in the software, that really just means that it's a constant tool engagement. You're trying to maintain constant tool engagement. So I'm going to go ahead and hit next here. Then we have our bottom allowance. We want to leave it 0. We want to finish the floor. And I can't even set this to multiple depths. So if I wanted to add multiple passes to do it a couple times, I actually can't do that here. Then we have our leads. Now the adaptive starts off the part already, but I may want a small little lead. I'm just going to add an extra 1/4 inch so that I can make sure that I'm clearing the material completely. Then we have our linking. If you have a gap within the model that's 200% of the tool diameter by default, you can change that value. It will retract over that, but it has to be whatever percent of the tool diameter or larger for that to work. If you disable this, it just covers over any gaps that you may have as if they weren't even there. Then we have our advanced feed rates, which we're not using, but we can adjust our lead in and lead out feed rate percentage and convert rapids to a feed. And then lastly, we have our MDI. This is also new to 35, V10, and V3 for Rhino. Now you can add in optional stops. You can pretty much add in anything you need that was not a advertised function from before. Outside of maybe drill banks and such, if you're doing a pallet changer, you could probably do that all through the MDI depending on the way the code looks. So I'm going to go ahead and hit compute. And then I have my facing operation. Now I'm going to go ahead and blank that. So I'm going to click on the little eye on the mill facing operation there just to hide that operation so I don't have the toolpath there. I can also do that for the stock as well if I need. Now I'm going to right click machine setup 1 and I'm going to do a mill 2 axis. I'm going to do the pocket on the inside. So I'll go ahead and hit select geometry and I'm just going to pick that polyline. Now because we're in the Rhino environment, they do support polylines. They have polylines. If I join a segment, I just have one click to pick my segment. Then I need to set my chain direction. I need to double check it. And I keep right clicking or using the center mouse button to rotate, and I don't need to. So my start point is where this arrow is. If I click on that arrow, it reverses direction, but I want to be left of that line to get climb mill going around it. So I'm going to keep my arrow going that way. Now the depth of cut, I made my stock 1 inch thick. Let's say we're actually only going about 3/8 down, and this part's maybe only 3/4 inch thick overall. So I'll go ahead and hit next. So on our feature page, now we have our rapid plane and our feed plane, which are relative to the top of feature. So rapid planes where you're rapiding from one operation to the next or one cut to the next. It's lifting 200 thousandths above 0. Now top of part or top of feature is not necessarily top of part, it is top of feature. That means that your feature could be in a negative position. So you could have a pocket within a pocket. I typically, if I have a negative top of feature, I add that negative value as a positive to the rapid plane. You make sure you clear any walls, anything you might collide with, because these are all incremental and they're all relative to each other. So if you increment one, they all move together. The feed plane is where we rapid down to before we start the plunge feed into the material. And then your total depth is how far down we're going from the top of feature. Again, so if you're doing a total of 1 inch, but you're starting a 1/2 inch down, your top of feature would be negative 1/2 inch, your total depth would be 1/2 inch. And it is always a positive number for depth. We already know that you're going down. If you put a negative number in there, we're actually going to go the other way. And since this is a closed shape, I cannot use extensions. Extensions can only be used on an open shape. So I'll go ahead and hit next. Then we have our machining strategy. Now I'm going to tell this that I want to do a pocket. That automatically adds a pocket and a profile finish, so I can compensate to finish the walls. You do have options for tabs on all the 2-axis operations, but they only work on profiling. So if you're using laser plasma water jet or a router or something, or just doing small parts in a mill at a larger plate, tabs will help hold your part to the rest of the remaining stock model. It just lifts the tool and keeps a connection. The posting page we don't need. We'll go ahead and hit next. Then we've got our tool. Now you'll notice it defaulted to the last tool I used. I'm definitely not using that one for this. So let's say we're using maybe a 1/2 inch to rough this out. Now my patterns, you have standard pockets and advanced pocket. Now I prefer advanced pocket. You do get a little bit more options. And I found that some of the calculations tend to be a little bit better. With that, you have parallel, offset pocket out, which starts in the middle, works its way out. Offset end starts in the outside, works inward. Then you'll have a morph spiral, which takes your shape and makes a spiral out of it. And then you also have adaptive roughing. For this one, I'll go ahead and do morph spiral. We'll change it up a little bit. And I'll go ahead and hit next. Pocket and profile rough will default to having 15 thousandths side allowance. So if you want to change that and save a default, you can. So if you're leaving 20 or 30 typically, you can actually save your defaults for that operation. I'm going to leave it 15 for now, but I am going to do this in maybe a couple passes, and I'll just do it in 2 passes. Next page, we have our entry. I may want to spiral into that, and I'll say the angle of approach on that spiral is maybe 7 degrees. 3 is very shallow. It would have a lot of passes to get there. And new to this version, we have the use lead out. This is a percentage of your step over. It'll do a radius away from the part before retracting. So if your pocket's right up against the wall and you're trying to finish, you can retract away from the wall before you retract. And you know what? I'll throw that on here just so you guys can see it. Machining sequence, we only have the one shape, so this actually does not affect anything. The start position has no bearing on the path at all. Linking, we're just going to do direct. There's really no need for the links here. And then we have our advanced feed rates, which if you are using the advanced pocketing, you can have the adaptive volume control, volume-based control. So what this is as I enter more volume of material, my feed rate will actually reduce based on the minimum percentage of the max feed rate. Then we have our MDI, and then our profile finish. Now the finish, I'm just going to go in here with let's do a 1/4 inch. You know what? Let's do a 3/16. I'm going to go a little bit smaller. And if you type in a diameter here, it should pull from the library if it has it. It will check the crib first if you have defined your tool crib initially. If it doesn't find a tool in the crib, it'll go to the library. And if there's nothing in the library that exists, like say I put a radius on here of 20 thou, it gives you a label like so. That label indicates that that is a generated toolpath. That's not going to exist the next time you go into Bobcat. So just keep that in mind. If you have to define that tool, you're going to want to go to the library and actually physically define it before moving on, if you want to go back to that tool at some point. Next page, we have our compensation. So you do have system comp, which offsets for the radius of the tool automatically in Bobcat based on the geometry you've selected. You also have machine comp. If you use system comp off, we're going to give you toolpath directly on the geometry you gave us, and then the machine offsets it for the offset registry for the diameter of that tool defined. In my last shop, I actually used both. So I would program for a 3/8 diameter mostly to cut out my parts. And if I had to change the tool mid-job, I would just throw in a reground tool that I might have to adjust my compensation in the machine negative the difference from the original size. So if it was 15 thou smaller, I would just do -15 in the control and it would offset and I wouldn't have to reprogram anything. That's a really handy setup for wear comp if you're using the same diameter tool all the time. But if you're changing diameters constantly, you're better off probably just using G41 comp by itself. They did add spring passes in this version, so you can now enable that. Now the spring passes, if you do not check this box, it will lead into the part, do its initial pass, continue around one more time, and then lead out. If you check this box, we will lead in, go around, lead out, lead back in for the spring pass, and then lead out to finish the pass. If you do multiple depths, you can also have it apply to each depth of cut or only the last depth of cut. So that button is not here unless you go back from the next page if you set multiple depths. So I'm going to set it to multiple depths. I'm going to go back. Now I have apply to all depths. And if I turn that off, it just does it for the last pass. Now the parameters, I am going to leave it on even depths, 3/16 per pass. Actually, you know what? Let's do a little bit less than that. Let's divide that in half. Let's do... You can do math in every field of the Bob Cam portion. So if I put in 3/8 divided by 4, it's going to give me 4 even passes. And I turned on the minimize retract, so when it leads out, it'll just plunge to the next depth and then lead in and then continue. Our leads, I'm going to do a small right angle lead. Now I do need to do at least half of the tool, so I'm going to do about 100 thousandths. That should compensate for the extra 15 thou or so I got on the walls, at least close to it. Corner types I don't need in this situation. Machining sequence, again, I only have the one shape, so this doesn't do anything. My advanced feed rates, you do have a corner slowdown, but I don't really have any corners I need that on. And then my MDI. So I'm going to go ahead and hit compute. So there's my path. I can see the spiral entry coming in. I can see my lead in and lead out for the profile, and it is directly on the line. And that is, again, because I am using G41 comp. If I use system compensation, everything will be offset. So now it's offset for that path. And that actually changes where the lead in is kind of coming in from too. So you can see instead of it being like a V coming into it, in and out of it, it's now just one specific spot. And I can see that morph spiral coming through there. Now I'm going to go ahead and hide that path. And let's say I need to do the outside. So we have this as, let's say, 3/4 inch thickness. I'm going to go ahead and right click machine setup 1 again and go to mill 2 axis. Go ahead and select geometry, and I'll pick that polyline. Now I definitely want to check my direction because, again, the default direction, left, will always be internal because we assume if you're picking a pocket, we'd rather you not have to switch the direction on the pocket. But on profile, you do need to double check to make sure that you're on the outside. So I'm going to click on that arrow, and now left will be external to this part, and I'll be cutting on the outside. Now I'll go ahead and set my depth to 3/4 and hit OK. And next. So pretty much the same thing here. I really don't need to do anything on the first page. My depth is already set. I'm going to do a profile rough and finish, but you know what? I'm also going to add a chamfer mill. So we'll go ahead and hit next from there. I do not need to select any tabs for this. I don't need the posting page. And then the profile rough, it's using the same tool that was used previously, so I'm okay with that one. I'm going to do left compensation, standard pattern. Now with profile rough, you also get contour ramping, which gradually cuts down in Z as you go down, or side roughing. So I could take a couple steps inward to this path, but I'm just going to do it as standard. We have our depth, which I'm going to do a few depths of cut. Let's maybe make that about 3/16 per. And I'll turn on the minimize retract so that it just plunges down to the next depth. And the profile, again, does leave 15 thou for side allowance. Leads, we're doing a lead in and lead out. Let's just go ahead, maybe do a circular this time. Now with circular, you have a right angle lead or a tangent lead. I prefer tangent myself. And then the length, I'm just going to make that about 100 thou for each. And the sweep angle, I'm going to go about 45 degrees. So it's just not quite of a sharp turn coming into the part. Corner types we don't need because we don't really have any corners here. Machining sequence, again, we only have the one shape, so this doesn't do anything. And we don't need the advanced feed rates or MDI. Then we got our finish. Again, this one does pull up the next tool because we've already used a finish tool. I'm doing left comp. I might add a spring pass on this one as well. Do a few depths of cut, maybe do about the same. And I'll minimize retracts as well on this one. Now let's go ahead and we'll use circular again. This time I'll leave it on right angle so you can see the difference. We'll do 45-degree on that too. We don't need the corner type, machining sequence, pretty much don't need the next until I get to the next tool. I'm going to say we're going to go in with a 1/4 inch, 90-degree, but I'm going to make it a flat. So let's actually go to the tool crib. And then I need to add from my tool library. So I'm going to add from tool library. And I believe I have a flat one. So if I look at the small diameter, I don't have a flat one defined. So I'm going to go ahead and add one. That's going to add a blank tool. If I double click on that or click on this little arrow, it'll expand the parameters. I'm going to say there's a 250, 90-degree. So my diameter is 250, angle's 90, small diameter is 0. You can assign a tool holder, and you can even go in and assign specific speeds and feeds for this tool. So if you use the same materials all the time, you can actually set your speeds and feeds before you even bring the tool into the job. But I'm going to go ahead and grab that tool and hit OK again. And now that brings it into my job. Now, having the 0 small diameter is going to give you an error when you go a couple pages down the line. So let's go ahead and hit next. This next page looks exactly like regular profile finish. I'm going to add the spring pass. And then I get my error. The small diameter can't be less than 0 since the flat bottom tool is selected in the parameters. The default selects this as flat bottom tool. All I have to do is select sharp and it resolves the issue. Now, when you're in the chamfer milling, the first thing to look at is the cutter position. This image is showing from the tip of the flute how much we're shifting the tool over to get to a cutting edge. So if you're on a sharp tool, we just go from the tip of the tool. It's center line. If you're on a flat bottom tool, we take the center diameter and divide that in half to get to the center of the flute, and then shift over. So we're doing all the math for you to figure out where you're calculating from. You have your chamfer angle. Now I can't change the value here because of our tools won't change on you. So I have to actually go back and change the tool to physically change that angle. And then we have our depth, length, or width to make that chamfer work. So I'm just going to go with the depth and let's say 25 thou. You also do have single or multiple depths. I'm just going to do it on single depth, but multiple depths, you can do a just straight depth of cut if you're doing multiple passes, or you can do a depth and step over if you're doing a chamfer bigger than the flute that you have available to you. Then we have our leads. So we're going to go ahead and do a blended lead on this one. This one is a little different. So blended lead blends the length and the radius to create a teardrop shape so that the tool starts and stops at the exact position. I'm going to both make those 100 thou, so they're 100 thou across the board on all of our lead ends. Then we have corner types, which we don't need, machining sequence we don't need, advanced feed rates, and the MDI we're good on, so I can hit compute. So there's my tool path. Let's go ahead and take a look at simulation. Now, if you're going into simulation and you want to see full screen, make sure you're viewed on one panel because simulation will only load in the panel that is active and you want it to be full screen. So again, make sure if you are working in your 4 screens here, double click the perspective or top or one of them so that when you load simulation, it's fully on that screen. Oh, and that's going a little fast. Let's go ahead and slow that down. Now, it's not going to show that it's removing any material with this adaptive facing because I didn't add any stock to that. If I want to add stock to it, I can always go back and adjust the stock definition to simulate that I'm removing material. So there's the adaptive. Now it's doing the spiral going into the pocket in the middle. Now it will automatically by default organize my machining order by tool number. So it did that face mill. Once it's done with this tool, then it's going to do the profile rough on the outside. So you do have to be cautious of that. Depending on the type of machining you're doing, that may benefit you or not. I know there's jobs that I've had where I've needed to program in the order that I've added the tools, and there's times I've needed to do it in by tool number. So it does vary. Just make sure you pay attention to that machining order. We'll take a look at it here in a second when this is done. I'll actually speed it up just a fuzz. And I can see the tool's not lifting, so it is keeping that tool down. Now it's shifting over to the 3/16, doing the finish. And it should do a spring pass right here. Yep. Now it's doing the step down going around. And it is quite a bit of material that it's taking out in that corner there, but it's all digital for now. So. And it should go around one more time without retracting because I got the spring pass on. And now my chamfer. Now, keep in mind when you're running simulation, it does run at a lower resolution. Once it stops, these areas that are kind of jagged do clean up. So there's my part. Looks pretty good. I'm ready to post this out. So I'm going to go ahead and close this. Now, if I needed to change any of the machining order, that's done now in the Operations tab. So if any of you have used V2 or under, or any of the other BobCam plugins or BobCAD standalone, this is all new. So I can see the facing, then it does pocketing, then the rough, then the finish, then the other finish, and then the chamfer. I may want to rearrange that stuff. I can do that all here. You know, for instance, if I wanted to take the rough, the finish for that, and the chamfer mill, and I'm just holding control to multiple pick those, I can move these up. Whoops. If you double click it, it will adjust the toolpath. Actually, I could just grab this one and move it down, or maybe move it before the chamfer mill. Yeah, move the chamfer mill down so it does pocket, rough, finish, and then finish. Yeah, you can adjust it really any way you need from this Operations tab. This one doesn't have a lot of variation that I could do. You still have the old options of individual feature, which will put it in the order that I programmed it. So now it's facing, pocket, finish, profile, finish, chamfer. And all of these flyout menus, if I click on that, I can change speeds and feeds, you know, right on the fly. So if you're sending the program to somebody else or you don't remember what you had, you can always hover over your speeds and feeds little flyout menu and see what's there. And on the cam tree, you can actually see that for each individual feature, you can change the rapid and feed plane. So if you notice you're crashing in simulation on a rapid, you can adjust that. On the machine level, you can change your clearance plane and work offset number. Tools, you can see the tool numbers. And on the job level, you can change your program number. So those flyout menus do help out a little bit too. Now this dropdown also does have buttons that you can change to big tabs just by clicking on those little 4 little buttons there. We have our tool tree. Now the really cool thing about the tool tree, let's say I wanted to change my 1/2 inch flat end mill to a 3/8. I can just right click that feature or that tool and go to replace. It's going to prompt me that says the tool is currently in use. Do you want to change that tool in all operations that use it? And I want to hit yes. So I'm going to go with the, let's say 3/8. Now it's going to flag those features. They both have little red asterisks on them. I'm just going to right click that tool and compute those paths. And now if I go to simulate, it's going to have the updated tool. So I don't have to go into each feature anymore and adjust the tooling. Because of the new setup we have for tools, it could change it all in one fell swoop. You can even reassociate what operations use what tools. If I wanted everything to use the 3/16, I could actually drag these operations to that tool. And actually I have 2 3/16 and flat end mills, so I don't want two. I want to drag this one up to the other. I can right click on that and compute it. Now that got rid of that other tool because it automatically made that one for me. And I'm sure most of you that have used Bobcat before have had that happen before, where it just generated another tool because the flute length was needing to be different or some variance happened. That generates a different tool. So the tool tree really does help you narrow those down and find them and change them really quick. But I can take all my features, my roughing, and I can make those the 3/16 end mill. Oh, my helical ramp diameter. Yeah, I have to change that if I would do the pocket. There are some stipulations on that. Like I can't have that big of a radius for that small of a tool. It's little things like that. Now, the other thing in the new plugin for all three is if I hit start simulation, it just reloads it. And it loads it at a much faster rate. So now I should be able to see the whole job done with the 3/16 end mill and the 2-inch and chamfer mill. So in this version, we added a lot of ways to really quickly edit and manage your job. Now, I do have a little bit of a boss there due to probably step overs with the morph spiral. I'd probably have to do slightly smaller. It's percentage based, but sometimes 50% will leave little bosses like that. And finally, when everything's all said and done and I'm ready to post my code, I just right-click milling job and go to post. It's going to generate my G code over here that I can just send right to my CNC or take it to the NC editor to edit anything I need to, or save to take it to a flash drive or send it to your RNC RS-232 computer or whatever you might have to get it to your machine. All right, so let's take a look at another part. So I'm going to go ahead and open this guy right here. Now my plugin is still open because I just opened a new file and it closed the last one. Now this one's already in perspective, but you do have your multiple views. I've already set this to shaded. You do have rendered as well, but I find shaded is easier to select everything. Now this one's actually going to be a pretty quick example. One of the things that we've added over the years was a hole recognition. So I'm going to do the same thing. I'm going to set up a new milling job. We're going to go ahead and set up our workpiece now because we do have a solid model. I'm going to set this as round stock and hit calculate. So now I have a cylindrical stock file there. Now I can see the diameter is 6 3/4. Let's just make that 7. Height is 1. That should be fine. Now you don't have to over define your stock. If you're holding on to a 1/4 inch underneath that and you're going to face it off or take it to a chop saw or something and cut it off, that's fine. You don't have to define it. Even with 3-axis, it's sometimes better to not define it so that you don't accidentally cut something that you don't want to. So I'm going to hit next. And then we've got our origin, and I'm going to keep it right there in the center. So we'll just go down and hit OK. Now, one of the things, like I said, that we've added was this hole recognition. Now, hole recognition, that's where the knowledge base comes in. But what this is essentially is you have your selected geometry you pick. Now I'm just going to pick the whole body. I'm going to tell it the minimum hole diameter. Wow, 10 thousandths. Okay. So this shouldn't pick the radiuses on the outside, but I tell you what, it does. Not sure why. I'll have to report that a little bit later. But this hole recognition, I could see all of the holes that it's trying to define here. And by clicking each feature, I can see what hole that is. So there's an 1.5 inch hole in the middle. I'm probably not going to drill to 1.5 inch, but I have an 1.5 inch hole. I have my second feature, which is these holes. Those are 3/8. Now I might even say those are tapped holes. I can define it as a tapped hole right here within my operation. That feature I don't need, so I'm going to just uncheck that one. It won't post it. It won't calculate anything for that. And then the last one is picking up the counterbore. It's seeing the 2 concentric holes and defining the entire job. It has the top, the bottom, top of the counterbore, bottom of the counterbore. Everything is defined for me automatically. So I'm going to go ahead and hit compute. Now that just gave me all my toolpath, but I might not want the 1.5 inch because I'm not really going to drill that. I might change that to a different size. So I'm actually going to delete all these. And how we come up with the method for cutting these parts is using this knowledge base. So the knowledge base up here on the BobCam tab is going to have, or your toolbar, sorry. You have your basic template here. You can add your own new templates, but for a hole, we're saying if it has a chamfer, if the chamfer diameter is less than 5/8, do a chamfer drill. If it's greater than or equal to 5/8, do it as a chamfer mill. Now, I don't typically use chamfer drills, so I'm going to change mine to chamfer mill. Or I might tell it to chamfer drill, but maybe 5/8 is a little big. Maybe if it's under 3/16, and maybe if it's equal to or greater than 3/16, I want a chamfer mill. Yeah, those are the ways we're defining all of the details of the drill. Yeah, the parameter for the depth. If the depth is greater than 3 times the diameter or less than 3 times the diameter, single depth. If it's greater than or equal to 3 times the diameter, change to pecking. And it's those little settings that help us define the holes. Counterbore holes, same deal. If it has a counterbore diameter of just over 1/2 inch, or if it has less than just 1/2 inch, do a counterbore drill. If it has over, do a counterbore mill. Now, to be honest, I don't hardly ever use counterbore drill, so I'm going to change that to mill and hit save. So I'll hit OK. So I'm going to go ahead and go back into this and go to hole recognition, pick the same model, hit OK. Now I know I don't need group, what was it, 3? Yep, that group I don't need. The first hole, I'm actually going to tell this that it's a counterbore hole, because one of the things you can do is you can define it as 1 inch. I'm going to drill it at 1 inch. Or you know what? Let's even just do this as a hole. Let's say I drill it at 3/4. We'll bring something else into this. That's a 1 inch depth. Then I got my 3/8 1 inch depth. Maybe change that to a tapped hole. Now I didn't add any properties to that, so it doesn't know the thread, but we're going to see what happens. Then we've got our 1/2 inch hole, or yeah, those are the ones that are not going in. Those are the fillets on the outside. And then we have our 1/4 inch counterbore hole with the 563 counterbore diameter, 1/2 inch depth. So I'm going to go ahead and hit compute. And if I look at the feature tapped hole, I'm going to go ahead and edit this. The basic strategy, and it did not pick my thread type. So I need to go in here. I'm going to do UNC. Because I didn't add a property to that thread, it doesn't know. And that's where the add properties come in. So I'm going to have to go in here and add it 3/8/16 so that it knows what I'm actually doing. So now if I keep clicking through, I should see the 5/16 drill, and the tap should be the 3/8/16. Okay, so that's another thing that I can adjust on that. So these are things that when you're using the feature recognition or the hole recognition, you're going to want to know ahead of time. If you bring in a model, it doesn't know that those holes are tapped. Whoops. So what you want to do, I want to define those as tapped holes. So I'm going to delete those again because it's very easy to get them back. And I'm going to add a property. Ooh, do I have to pick both halves? Probably not. We're going to pick one side and we're going to see what happens. So I'm going to tell it UNC 3/8/16. So I've added that property to those holes. So now when I go in and do my hole recognition and pick the solid body, I should see hole 1.5 inch, which I know. I'll change that to 3/4. And we've got the tapped hole going around, and you can even see the diameter that it's showing is the 5/16. Then we've got the 1/2 inch, which we don't need, and then the 1/4 inch counterbore. So I'll hit compute. So let's go ahead and run simulation. We'll slow it down a little bit. So the same center drill is being used for all of these features. So it doesn't have to change tool between each one of those. A lot of people's first instinct is to say, oh, I'm going to center drill all of these holes. So I'm going to make a feature for center drill and pick all of them. And that's really counterintuitive to the way Bobcat works. Even if you're not using the hole recognition, you're building out all of the features you're doing at one time. Now, I find for counterbore holes, hole recognition is way easier because it defines all of it for you. If you separate them out into multiple features, you do have to know the information about the hole. So keep that in mind when you're going to do drilling. If you're doing a lot of counterbores and you don't know much about the drawing, you may need to go in and adjust that. Now, one thing I did want to show on this part, I drilled this to 3/4 inch, and everything else looks pretty good. So I have a 3/4 inch diameter hole in the center going to 1.5 inch diameter. So I might want to pocket that out. I might want to do a spiral pocket. So I'm going to add a new layer. I'm going to make that my active layer, and I'm going to change the color. Let's go ahead and just do a blue. I'm used to Bobcat, so I'm going to go with blue. Let's go ahead and add a circle, center radius. So I'm going to go off the center here to that diameter, and if I hide my CAD, I have my hole there. And I'm going to do the same thing. So we're going to add another center arc, and I'm going to make this one, let's do a radius of 3/8. Okay, now that one on the inside, I'm going to hide the solid real quick. This one here, I'm going to go to my properties and change this line type to a dashed. So now I'm going to go into my machine setup, and I'm going to go to mill 2 axis. Select geometry, and I'm going to pick both of these, that and that. Now depth, we're going to go 1 inch, since that's the full depth of part. And now it does show solid here. However, when you're using the advanced pocket, it should see that as an open side. And I'm actually just going to get rid of the profile finish. We'll just do this as a pocket. Actually, you know what? We'll do pocket and then a profile rough. Something's going on with the stream there. I'm not sure. Just kind of disconnected, and it's looks like it should be coming back up there. All right, sorry about that, everybody. I don't know what happened there. Okay, so anyways, I'm going to do pocket and profile rough on this. So the pocket, I'm going to spiral out using the 1/4 inch end mill because there's only one end mill already used. I'm going to just go with that one. I'm going to tell it to do an advanced pocket and use spiral for a circular pocket. So this should automatically spiral from the center, knowing that I've already removed the 3/4 inch area. And you know what? We'll do a little smaller step over, let's say 40%. I'm going to leave that side allowance because the profile rough is going to take it out. And let's make it a little bigger. Let's say 20 thou. We'll do multiple depths on this, maybe about 1/4 inch per pass. I don't need to do any entries because it's going to see the dashed line. And even if I turn this on, it shouldn't use it. So let's go ahead and turn it on anyways. Maybe it'll make me a liar. Let's find out. Machine setup, or the machine sequence I don't need. Linking we don't need, which we do have a new option for minimizing links. I do keep it off unless I need it. I have run into issues where I've had it on and it didn't need it. It did some goofy things. So that's an option you want to do as like kind of a last thing. Profile rough, I'm going to use the same tool, but on this one, I'm going to do contour ramping. So we're going to circle interpolate that hole all the way down with that 1/4 inch. Maybe even add a spring pass at the bottom. Now, when you do contour ramping, you can either do a depth per pass or you can do an angle. I'm going to do a depth per, and let's say I want to do about 1/8 inch per 360 degrees. I can also utilize our brand new entry point. There is a lead from center. This will automatically find the center of whatever cavity you pick. So if you pick multiple pockets that you're doing, it'll find the center of each one of those. You also have a point blend where you can add a radius. So if I needed to do like a little little radius coming into the part. This will still plunge into the center and then do an arc in. And I don't need corner types, machining sequence, advanced feed rate, or the MDI. So I'll hit compute. And I keep hitting the middle mouse button. So there's our paths. Let's go ahead and blank all of this out. So the pocket, it's doing that spiral. It's only doing the little bit it needs to, because there's not much material it needs to cut. Then that profile rough, it's just leading in and spiraling all the way down. So we'll kind of go through this one more time. I know we already saw the drills, but sometimes it's just nice watching simulation. Now I could get rid of that chamfer. That's on the tap. The default definition for a tap is going to do the center drill, chamfer drill, and tap. I really wouldn't do the chamfer drill. If I did a chamfer, I would actually probably do another center drill. One of the things that I like about the center drill function, and maybe we'll veer off and I'll do this as a separate thing, but with the center drill, you can either define a center diameter you're trying to achieve. Oh, and that totally went off. It's still using that spiral, so it did make a liar out of me. We're going to turn that right off. And it looks like it's not even recognizing the dashed line. So let's find out why. That may be something I have to report, because it's treating it like it's a closed pocket. Because I know it works going on the outside. Now, the other way to address that, so that pocketing, we do internal advanced pockets. I'll just have to double check with development of why that's not working there. But the other way around that. So I wanted to use the spiral, but that's all right. I don't have to. I can do it as two profile roughs. So if one rough is doing side roughing, and I say I have 3/4 inch material, and I want to do 3 passes. Let's do more than that. Let's say 6. I can still do the spring pass. I could still do multiple passes. Let's do it at 8. We'll minimize retracts. And I'm not going to do the full start from center. Actually, you know what? Start from center will work just fine on that one, because it is coming from the middle. It's the finish that I'm not going to do that. So the finish, now I'm going to do the contour ramp with the spring pass. No side allowance. Make sure I have a side allowance in the first one. We'll do depth per pass, 1/8 inch. This one we'll do point from center. Actually, this one we don't need to do point from center, so I'll just do right angle. And I'll say 100 thousandths. I don't need corner type, machining sequence, and so on, so we'll hit compute. There we've got our spiral down, and then our side roughing coming in. So I need to adjust that side roughing. Holy cow. It's actually 3/8 per side. That's right. 3 passes. There we go. That's what I wanted to see. I overdefined it. I gave it total, not per side. Now I want to disable that chamfer drill. So if I just hit the post yes, no here and hit start simulation again, it'll actually get rid of it, and we won't even see that operation happen in the simulation at all. And it's all right, the open pocket didn't work on this one. We are going to look at an open pocket on the next part. So that's fine. That works on the outside at least. That's where most of the open pockets are. A lot of open pocketing you can get away with doing the side roughing on profile if it's an internal one, but definitely should have that looked at to see why it's not not working. And again, I might want to check the tools to see if it didn't double up anything. So I've got my number 5 center drill, 3/4 drill, 5/16, the chamfer, which I'm not using, the tap, quarter drill, and then 1/4 inch flat end mill. So I'm not seeing any double tools or anything like that. Everything's looking pretty good. There's my side roughing. And just for fun, let's make the visibility transparent. So when we get down in there, you can see it doing the spiral. Now, drilling and milling, they're pretty easy to set up features. You can save features. So if this was a very common feature that I would go in, do the side roughing, and then do the contour ramping going down the wall, if I did that often, I could go in and save that feature. Now, saving milling features and turning features and such, that's fine. You can save those all day long. That'll benefit you in the future. Drilling features, on the other hand, I typically don't save. We have some automatic things built in with drilling that may reset your depth if you reselect stuff. So if you're planning on a drill being 1-inch depth when you load it in, after you saved it and you pick new geometry, it might not be 1-inch depth anymore. Drilling does an automatic kind of depth selection based on what you're picking. So keep that in mind if you're saving features. The drills are not really worth saving most of the time, but the cam, like the other cam features, profiles, pockets, those are all definitely worth saving if you're doing it all the time, the same amount, same tooling. Now, I'm not going to worry about cutting the outside of this part. We'll just say that's what we wanted to do on this one. I'll go ahead and right-click milling gel. You know what? We will do the outside because I don't have a wireframe to select from. So this will kind of get into how to select that to hide that other layer. So now I have a solid instead of just wireframe. So when I go into a mill 2-axis feature and I select geometry, if I pick an edge, I'm seeing surfaces. So if I hold Control and Shift and click that edge, I now get Poly Surface Boundary as an option. That's the one I want to use. Then I want to click Pick Bottom, and I could pick the bottom edge of the model, and it defines the depth for me. I just want to double check my chain direction. I see my arrows right there, and if I'm left of that, I'm on the inside. So I want to click on the chain and reverse direction. I might even want that right there, just so it's starting right on that radius. So next. Yeah, just remember Control and Shift will let you pick the boundary area of a surface. So we'll do rough and finish. Actually, we'll just do this as a quick finish, because finish you can still do multiple depths. I just want to go to System Tool, uncheck that, and then I can grab that 1/4 inch flat end mill. So if I wanted to stay with one end mill the whole job, I can. I don't even have to go to the tool crib. Maybe throw a spring pass on here. And you know what? We'll turn on this apply to leads, so you'll all see what that does, but it's going to lead out before applying the spring pass. I will do definitely multiple depths on this. Let's say 1/8 inch per. Minimize retracts. And I might want to do let's do a blended lead. Blended lead, again, starts and stops in the same spot, making that little teardrop shape blended from the length and radius. No corner types are needed. Machining sequence is all good. And I don't really need the rest, so we'll hit compute. And that gives us our final part. Now, in simulation, we've already seen a lot of this stuff. I don't want to watch all this stuff every single time, and I know that's what I've been doing. So if I minimize some of the move list here and I scroll down, I can go down to my profile rough. Actually, let's do that one. Oh, that'll work. It'll do the contour ramp going down this, and then it'll do the profiles on the outside. So it only loaded up to what I needed. I can even pause the simulation, something not a lot of people know about, and scroll the mouse wheel through these movements here, and I could see what that tool's doing in all these different locations. Now, for any of you guys that do any 3D printing, some people are not aware of this, but in simulation, this is just an STL file. You can save this STL file out and print it. And if you have something that has 3-axis toolpaths, or if you're doing like a thread mill, it is a pretty accurate representation of it. So to do that, you would go to Cut Sim. But if I did that right now, it's going to have all these extra pieces. If I go to Measure, we have a Remove Chips based on volume, with Test, Auto Define. I'm going to do Select Chips. Actually, let's do Keep One Part. If I push the middle mouse button on the part I want to keep, everything else drops out. And I could save this part as an STL and load that into my 3D printer. That's really for stuff that you want to prototype, before you cut it on the mill. So everything looks good there. I'll go ahead and close my simulation. And again, to post out the job, I just go up to Milling Job, right-click on it and go to Post. I also have Generate Setup Sheet, which the setup sheets will give you a full cycle time. They'll take a screenshot of your part in the CAD area, total cycle time, number of operations. It'll give you your stock information and your tool info, as well as cycle times for each op. Now, the next big thing I really wanted to talk about was, what if somebody gave you an STL file? Now, STL files, typically, there's no edges. There's nothing there. It's just polygons. They're essentially an image of a 3D part. However, Rhino, because of the type of software that it is, handles STLs where you can pick edges. So if I load this STL, this should be the one I want. Oh, there goes my Rhino. Let's go ahead and send the crash report, open that bad boy back up. Now I'm going to drag and drop this, but for whatever reason, I think my default is set to, okay, there it is, STL inches, perfect. I'll show perspective. Now this is just a STL model. There's my shaded render of it. And when you have an STL file, typically, and just to kind of show this as an example, if I go into BobCAD, there's no edges to this. Same thing in SolidWorks most of the time. You're not going to have edges to these files. They're just essentially an image of a 3D model. So just to kind of give you a reality of like what I'm talking about here is, if I load that part into BobCAD, I can't hardly see it just because it's one color. It's just white. But if I change the color of it, there is no edges there's not a single edge to this piece. I can't go in and extract edges and pick anything. There's nothing to pick. It's not even a solid. I can't do anything with this besides 3-axis milling in BobCAD. But when you're in the Rhino plugin, that STL becomes something that you can actually pick edges. You can pick stuff off this. So if I load my BobCam plugin, and I could just type in BobCAD, or BobCam. So if you're used to doing the command prompts, you can type in your BobCam, get your cam tree. And I'm just going to go ahead and right-click and go to New Job. Using that Haas mill, that's fine. I'll go to Stock Wizard. Select my workpiece. This is just a mesh file, so you can use that as a workpiece, but workpieces really don't do much for you but help you define the stock. So if you have fixturing in your workspace, or if you're drilling holes, that also does show. I'll go back to that hole example here if we have time before the end. Now I'm going to go with the basic stock definition this has. We're going to go ahead and hit next. And the machine setup, let's go ahead and throw that up on the top. Let's do top center actually. And okay. Now with a normal STL, you cannot do 2-axis milling, period, at all. But in Rhino, you can. So if I go to do a 2-axis mill, maybe I need to just cut that edge and this edge. So I'll look at my profile chains. I want them going opposite directions. So I can be left of this one, and that's correct. And then I need to flip that one. So I'm left of that one on that side. And then my total depth, I'll click pick bottom, and I can pick that edge. And again, this is all stuff you cannot do in either of the other plugins that we have. So I can see my geometry, my total depth. I can even add extensions now. So extensions is a percentage of tool diameter or a distance. If you click this button, it does not change the image though. That's something that we've talked to development about. I don't know if that's changing anytime soon or not, but when you see this whole number, that is a percentage of the tool diameter. I'm going to leave it 50. We'll hit next. I'm going to do this as a rough and finish as well as a chamfer mill. I think I put a 16th chamfer on the top, maybe even less, not 100% sure. Tabs, I don't need. Posting, I don't need. Then we got the profile rough. I'm just going to go ahead with the default tools, 1/2 inch. Now I want to say I have about 3/4 inch of material here. So what we'll do is we'll do side roughing. I'll do this as a 3/4 side remaining, and we'll do 3 passes. And on this one, I'm going to even do zigzag. Zigzag is new for our side roughing. I'll do it in multiple depths, and we'll do even at, say, 250. Now you can sort by slices or passes. So just like with the step over and step down with chamfer mill, slices is going to be each level, Z level, going down, going across the part. And then passes would be a full depth before stepping over. So I'm going to keep that by slices. And I can even make my depth zigzag, but I'm going to keep it on zig. Really no sense to have both of them zigzag. We're going to go ahead and add a circular lead. I'm going to do it tangent, 100 thousandths in, and we'll maybe do 45-degree radius. And we'll hit next till we get to our finish. So finish, I'll use let's go with a little smaller. Left comp. I'm not going to do a spring pass on this one. We'll do single depth of cut. And I'll add a circular lead in as well. Keep in mind, if you are using G41 or G42, you do need to put the radius or more for the length of your lead, and a lot of machines require the same for the radius as well. So most machines need the length of the lead to apply comp. So we'll just next until we get to the next tool, and I'll go to my tool crib and grab that sharp tool. Left comp. We're going to get that error again. I'm just going to switch it to a sharp tool, and I should be able to go to pick bottom and actually pick the physical bottom of that chamfer. So it was a 62.5 thou chamfer. My cutter position's 20 thousandths, so I'm shifted over, and it's a 45-degree. I can do multiple depths with this one as well. I could either just have it do depths of cut, so I could say 10 per. It'll do 7 passes because it'll do 6 at 10 and then 1 at 2.5. Let's say we do 15. Lead in, maybe I'll do the same circular lead. Tangent. And compute. So that looks pretty good there. Let's look at simulation. I don't know how many times people have come to me with a STL model that they wanted to mill, and there was nothing we could do to make it work. Now there are things in our standalone where you can get silhouettes of STL files, but that's something very new to the system. So yeah, it's one of those things that Rhino really is the best if you're dealing with STLs. Now, I thought I told this to go by slices. Let's add another zigzag to that just for fun here. Let's do a zigzag on here, compute, and then start simulation again. Just to see what that would look like, because I think that might be more efficient. Yep, there we go. Because if it's going to be going down each pass, might as well. Now, in simulation, another thing I have not mentioned, the left mouse button is your rotate, right mouse button is pan. So I know that's a little different than the Rhino environment. It's a little different than all three of the environments, to be honest. And for those of you who may be wondering why I'm not seeing all of my toolpath at one time on the screen, when I load a new version of BobCam or BobCAD, very first thing I do in simulation is, one, I set my operations to current op only. By default, it's on all ops. By doing that, I'm only looking at one operation at a time. And then I also set it to segment. So I'm only looking at a small portion of the current operation running. That way I'm not flooded with a bunch of toolpath on my screen when I load simulation, especially when you're doing 3-axis. That can get really messy. And there's my chamfer. And it should do a couple passes. At least that's what I thought I told it to do. Yep. Interesting. All right, let's turn the step over on that too. Let's do it at 15. Compute. Let's double check that. So I just want to see that chamfer. So I'm going to click on chamfer mill. No, that's doing the full 16. Oh, that's doing the step over now. Interesting. It's doing the step over, but not the depth. And it looks like it's working from the bottom up. That would be counterintuitive there. All right, so next thing on this one, the pocket, right in the middle here. Whoa. So to do that, recompute that just to get rid of that flag. I want to go to mill 2-axis, but with an STL, I did find you cannot use the detect open edges for pockets. That's a feature that we have when you go into geometry selection in a 2-axis feature. You can detect open edges. And I tried doing this earlier on this face here and here, and it didn't see the ends. So in order to actually make this an open pocket, what I want to do is I'll add a new layer. I'll change the color of the geometry here. And then I'm going to go to curve and line segments, I think is the one I want. And I'm going to sketch a little line all the way around and then hide that model. And I just put that stuff on the wrong layer. Okay, so let's add that layer back in here. Move the check mark to it and change the color. So curve, line segments. And I'm doing it in line segments because if I did it as a polyline, I didn't have to break it anyways. At least that's what I thought I had to do earlier. Oh. Oh, weird. There we go. So there's my my line segments. I'm going to go in and click on, is it Shift? Yeah. If you hold Shift and pick the two ends, then we go to our properties. I'm going to tell them that they're dashed. Just by having that, let's go ahead and compute that again. When I go into a mill 2 axis and select geometry, I will pick that chain. I'll turn my model back on. I want to set my bottom to there. And the chain direction really won't matter here because it's a pocket. It will know what to do. So got 3/8 depth. And I am going to turn on extensions. And I'm going to go in with a smaller tool for this. So I'm going to do pocketing with the finish. So let's go ahead with a 1/4 inch. Now I'm going to use the adaptive roughing. So adaptive roughing, and we even have an article on this on our main website. It's the Understanding the Adaptive Machining, the Axial and Radial Chip Thinning. I definitely recommend downloading that if you're interested in learning more. But again, adaptive just means that it's trying to maintain constant tool engagement. So keep that in mind. And it's controlled by the minimal curvature radius. So that's the smallest radius you're allowing it to do. Your step over, which typically with high speed machining, you're going down to like a 10% step over. A lot of tooling will recommend something like that. And again, if you read the articles on the Bobcat website, you will understand a little bit more about the chip thinning and the formulas involved. I am going to leave side allowance for the finish, but then we have this link clearance. So the link clearance is how much we're actually lifting to get to the other side. So if I'm just doing one cut direction, it has to relink the path. On that linking move, we output the machine's defined maximum feed rate to apply that to that segment. So understand you're going to get whatever max feed rate the machine has defaulted on it when you're using this adaptive on those retract moves. You also have this breakthrough amount. This is something that was added a few years ago. I'm going to leave it right in the middle for now, and then we'll take a look at it, maybe adjusting for toolpath. We're going to do single depth. I'm not going to worry about an entry. Machining sequence I don't need. I really don't need the rest of these pages here. And then we get the finish. So I'm going to use the same tool, 1/4 inch, left comp. And I'm really not going to set much on this one. Maybe just throw a lead in here. And compute. Now this does recognize that dashed line. So I'm not sure why the profile earlier wouldn't do this, but this one does work. And if I go into backplot, so if I right click a path and go to backplot, that brings the tool into the workspace, and I could run that tool's movements. Now you do have a speed here if you want to speed it up, so you can actually see the tool in the workspace running that part. And when you're watching this, if I pause it, the values down here are actually going to be relative to what's in your code. So if you're trying to troubleshoot something in your program, try backplotting your toolpath and see if those numbers line up. They should. But let's go ahead and simulate so we can actually see what it looks like. Now we're going to skip to the pocket. Whoa. Now the nice thing about length mode is you'll actually see the change in the feed rate. You'll notice as it engages, it's slower, and when it retracts, it goes a little bit faster. There's not a lot of movement there, so it's hard to tell, but length mode will actually represent that within the code, or represent that within the simulation. All right, let's see what other parts we can get into after this one. Now, one big thing with two-axis milling that haven't quite touched on, some of you may need this, some of you may not, is doing toolpath patterns. So we kind of know what the rest of this one's going to do. Let's look at the breakthrough amount. I'm going to actually bring that down to less and hit compute. Let's see if it changes the path. It actually adjusted it a little bit down here. Not much. It just looks like it shifted it slightly. Let's bump that up to all the way for more. See if it adds. Yeah, it tightened it up a little bit here. That's really all it's doing is it loosens this area or it tightens that up. So that's what that adaptive or the breakthrough amount is kind of doing. It just kind of lessens or reduces the amount of path at the end. Doesn't look nearly as dramatic as it does in the image. And when you're looking at the tricotial path like this, you can see that pink kind of movement, that is the retract. That's where it's using, and if I post this out, when I look at the code, and actually let's go in the NC editor so you can see it. And for those of you that do use the NC editor, the default font is very small. I actually go in and go to options and bump that display font size pretty big so I can actually see it. But in here, we'll see the plunge feed of 6 inches a minute. Then it goes to 13 when it starts cutting. And then when it retracts, it goes up to 600. So because it's high-speed machining, there's no change from feed to rapid move because most look-aheads can't do that. So actually, I don't think there's any look-aheads that really do that, but I could be wrong. So most all high-speed machining is all feed moves. So the retracts are just feed rates. So years ago, we added it where it'll use that maximum feed rate defined on the machine. So if any of you guys need to change that value, like if it's erroring your machine when you try to use this, if you go to CAM defaults, go to current settings, the maximum cutting feed rate is where that comes from. So you can change this value and it'll update everything. All right. So let's take a look at one more part, at least. Oh, which one do I want to do? Let's grab this guy. So I'm going to do an open. I don't want to change anything on that one. I think it was this guy. Yep. And I'm going to just delete the job that's on here. So this has a little bit of everything. There's a little bit of drilling, a little bit of pocketing, which we can do that as profiling. We can do that as drill. We've kind of seen a bunch of options there. So to start this job, I'm going to go to New Job under CAM Defaults. We're going to do milling. I'll pick my workpiece, and we'll kind of take this through the whole job. So I'm going to do rectangular stock. Let's make that 9 by 6. And let's make it 1 inch thick. Now, when you add that thickness, it's adding to the bottom. So I might actually have a block that's like 1.5 inches, but I might be facing off, 100 thousandths. So if I change my Z height to 850, it moves the stock up. But I still might want my 0 right at the top of the block, at the top of the material. Now the next page, if I'm setting my G54 in the upper left-hand corner, I'll pick origin. And again, if you don't have some of your snaps on, you might not be able to snap to that. But then I want to drop that down to 750 because I'm going to program 0 as, is it not going to let me? There we go, 750. And you can see it bumped that down. So now I'll right-click Machine Setup 1. We'll do a mill facing real fast. And again, I do not need to pick geometry, so I'll hit Next. Now you might have noticed this Keep Internal Loops and Bounding Box. Those don't really apply here because I have rectangular stock. If you're using a custom stock shape where you might have a giant area missing out of the middle, Keep Internal Loops will actually keep that section. And if you're running like a cylindrical part and you want to make it rectangular, Bounding Box will make a cylindrical or odd shaped part into a square bounding box area to face. So neither of those I need right now, and I don't run into too many times where I need those. Also, my top of feature is 100 thousandths because 0 is 100 thousandths below where the stock is currently at, and my total depth is the same value to get to 0. Again, total depth is always a positive number. The only number on this page that should be negative ever is top of feature, and that can be positive or negative. Then we got our mill facing operation, so I'll hit Next. I don't need the posting page, so I'll Next again. And then we got our rough, so I'm going to go in with a 2-inch face mill again. This time I'll do zigzag, but I have a little trick that a couple of years ago somebody asked me about the rapids, or the linking, asked if they can make those rapids. You can't convert those to rapids, but I do have a trick. If I take, let's say my feed rate's 25 inches a minute, plunging at 10. If I go to my arc slowdown and say I want to do 5,000% or 50,000% of that maximum feed rate, I can convert the linking moves instead of line to arc. Then the only arc moves in the code are when it links, and you're essentially turning your linking move into a rapid. You're just applying a feed rate to it. So to do that safely, I usually use off workpiece because this is a distance that you're leaving extra beyond the edge of the part. So I'll maybe come off an extra ½ inch. I might do a step over of 40% or so, going across the X direction. And I'll do a single depth, and I'll just hit Next. Same as lead in. I don't really need a lead in and lead out, but let's go ahead and add one. When you add a lead in, it's only going to add the lead to the initial entry and last exit of that path. It won't add it to every single path. And then I want to use arc. So as long as I switch this to an arc, this arc slowdown will output a much faster feed rate for when it links than when it feeds, doing the straight lines. You do have an advanced feed rates for this one as well as the MDI, but we don't need those, so we'll hit compute. So now if I go ahead and simulate this, which is that 2-inch? Yeah, that's 2-inch face mill. Okay. If I post this, go to my NC editor so we could all see it. And I just kind of threw numbers at it so we could see them very clearly. But we've got our plunge feed rate of 10, our cutting feed rate of 25, and as soon as it hits that radius, it goes to 600. So that actually worked out really well for one company I know at least, that they were needing a rapid on all their linking moves. That just worked out as a really good solution for that. And it is coming off the part far enough. So if I backplot this, we should see that tool engages, leads in, then comes off. It's coming off that extra ½ inch before it does the arc. It's going to do that 600 and then go back to the 25, 600, and then so on. And you'll even see the positions here. Like I said, you can check your G code versus this, and that should have the same values. So I've got my facing. I'm going to go ahead and hide that. Next, after the facing, I might drill this. And I might want to drill these and then maybe center drill this one. I've already got a point right in the center, but I don't even need the point for that. The point's for something else. So I'm going to go to Machine Setup. We're going to go to Mill Drill Hole. So I'll select Geometry, and I'm just going to pick the cylinders on the insides of these. If you have a solid, it's a good idea to pick the cylinder. We will automatically define the top and bottom of the part. So the diameter's coming in as 400 thou. I'm just going to change that to 3/8. Depth 750. And actually, let's go ahead and select Geometry one more time. I'm going to pick that guy in the center. So we'll say that's 3/8. And this one, the 2.5, is also 3/8. So now it went from 2 groups to 1 group for the holes. And they're all through holes. So I'll hit next. If I click on group 1, I should be able to see a 3D model of my feature. So there's my holes. I'm happy with that. I'm going to do center drill and drill. I don't need a machining sequence, but the machining sequence, it has optimized. You have the other options here. Optimize just kind of cycles through the rest and figures out a good result. You do have closest, but what you may think is closest is not always closest. There is a threshold to that. So if you do get confused, if there is a drilling pattern that's not kind of coming out the way you thought it should, just let us know and we'll take a look at it and hopefully we'll be able to explain it better for you. You do have a pick order, which I really like the pick order, to be honest. When you go into pick, you go in and you just drag your mouse through the order of the holes you want to do, and that sets your order. I click on the screen again to close it, and then click the check, and now my order is set. Not only is the order set, we have this reverse after each operation. It's going to go back in the opposite direction after the center drill when it goes to drill those. So it's not wasting a lot of time moving the table around. Posting page I don't need. Center drill, I'm just going to go ahead and go with the center drill that it gave me, the number 5. We did add pecking to this version, so if you need to peck, you can. It does divide it into 3 depths. Then the depth is either a depth of cut or a center diameter you're trying to get, and that center diameter is based off the center angle of the tool. But we'll just do single depth. I don't need the MDI. Then I'll do drill. So the drill is a 3/8 drill. Point angle defaults to 118. If you do need to change that, you just uncheck System Tool, click the drop down, and then Modify Tool. If I'm using like a 135, that will definitely change the overall depth on the next page. So if I uncheck cutting conditions, the effective depth is to 800 thousandths, but the overall depth, the effective is the full diameter of the drill. The overall depth is 878. That's with that included point angle. So we added 50 thou to the total depth and then the point angle to get to what we're going to in the code. We do have peck or fast peck. And if you don't know what those are, peck comes completely out of the hole, 100 thousandths above the part before going back in, where fast peck retracts 100 thousandths from the previous depth and then keeps going back in. Often referred to as a chip breaker toolpath. And then the last page is my MDI. So we'll go ahead and hit compute. And we've got our drills. Now I pre-drilled the center for this pocket. Maybe I need to mill that whole thing out. So I'm going to go to let's go ahead and blank that feature first. I'm going to go ahead and right click machine setup 1, go down to mill 2 axis, select geometry. And again, I hold Control and Shift to pick the poly surface boundary. Now my top is 0 because I've already faced it off. And my total depth is 750. Next. So I've got that represented in there. Next again. We'll do this as pocketing with a finish. I don't need tabs. I don't need the posting page. And let's go in. Let's say we use a 3/8 end mill. I'll do an advanced pocket. I always like to use the advanced pocket. We'll do circular if we can. The spiral if we can here. Side allowance we'll leave alone. And we'll add maybe a couple passes. Let's do 4. Don't need to worry about using the lead out, but you know what? I will just, I'll point it out this time. I know I turned it on before, but I didn't quite point out the exact position that it was in. And I don't need the rest of that, so I'll just go down to my profile finish. Maybe we'll go with an 1/8 inch tool. Left, maybe do a couple passes. I'll even do the point blend and give it a radius. And I don't need the rest of these pages, so I'll go ahead and hit compute. So the pocket, and let me go to a top view. The pocket is starting off center. So I want it to start dead center, and it doesn't seem like it used the lead out, so that might not be a feature within the spiral pocketing. I'll have to double check that. But I want it to start in the middle, and that's really what this is about. And if I go back to perspective, that point is at the bottom of the part. And that is a critical part. That point needs to be at the bottom of the model, whatever depth you're going to. So if I expand pocket here, there's a drill tip position. I'm going to right click on that and go to reselect and just pick that point. So now if I right click pocket and go to compute, it's plunging at dead center and then moving to the start. That is not a start point, it is a plunge point. So there is a distinction there. It's not necessarily starting your path from that spot, but it's entering and then moving to the start of the cut from there. So the spiral's not starting from that spot. And I know that there's been a lot of confusion about that in the past. A lot of people assume that that is the start of the cut, and it's not. All right. Now the last thing on this may be cutting the outside out. So I'll minimize these paths so I get more room in my cam tree. Right click machine setup 1, and we'll go to mill 2 axis. And again, I need to hold Control and Shift to get the poly surface boundary selection. If not, you're going to have to convert entities and create a polyline or lines to select. My profile chain, I want to be left of that line. So if I'm left of that, I'm actually going to be inside of it. So let's click on that arrow. So left is external. Top of feature 0. Total depth is 3/4. And then next. Don't need anything on this page. I'm going to do profile, rough, and finish. Don't need anything else there. Or the posting. It's already using my tools that I've grabbed from the other operations, so I'm just going to continue. I'm going to do standard pattern. Do multiple depths, maybe 200 thou per or so. Maybe add a lead in here. Let's do a little right angle lead. Next tool, we'll keep it that 1/8 inch. Left comp. Maybe do 2 passes since we're only taking 15 thou of the walls. And maybe do the same right angle lead. Really, I don't need the rest of these pages. I have corner type, machining sequence, advanced feed rate, MDI. Once you get comfortable with some of these features, you'll pick what you need and just hit compute and you're done. Now, this may be a common job. So if I do this job all the time, I'm using these same toolpaths, these same tools. One of the things that we've added over the years is you can actually save the job as a template. So if I save that job as a template, it's going to save my stock, my machine setup, my tools, and all my operations and their settings. So depending on the jobs you're doing, if you're working on like a router table, you can define a template with a 4x8 sheet as your stock with the origin already set, and then you're moving your parts into location. For instance, if I was using this as an example for that, a little nest where you're defining, the job. A lot of people, this is the only thing they do. You can actually define this as a template. So if I save this as a job template, and I'll just call this 4x8, help if I actually type the right numbers, 4x8 table. Now, if I delete that job, I now just have geometry on the screen. I don't have a job in here. If I go to job from template, which you have a button here, you have a button here, and you have right clicking and go into job from template. I'm going to go to the 4x8 table. I don't have any other templates in here. I don't use the Rhino plugin that often. And I'm not even going to go to stock wizard. I'm just going to hit OK. My stock is already there. My machine setup's already there. If I go to a perspective, you'll see it. My origin's already set up on the block on the top. All I have to do is go in and select geometry, which, depending on how you set up your parts, I use polylines as much as I can so that when I go to pick stuff, let's actually go to a top view. I can drag a box through it and I pick everything inside that box, and the polylines just pick the whole chain. I can click on them individually. I just find it to be easier to work with polylines. Now, when I compute that, all of these paths are on the inside. So I'm just going to right-click default chain start point and reverse that direction. right-click Profile Finish, and compute. So even if you mess up and you forget to set your chain direction, you have a very easy way to do that just by right-clicking Default Chain Start Point. Modify will let you go in and change where they lead in from. If I wanted all these to lead in from this position, I can go and set them to do so. And I used to have to do that on my routers a lot, where I have to go in and set specific lead-in positions so that I'd avoid other parts, or lead in so that parts are not going to go flying off the table. Now my lead-ins are all along that same line. So you can adjust where they're at, you can adjust the direction, but if they're all going the wrong way, that's where reverse direction comes into play. Now, I think that pretty much takes us to the end of today. That we covered just about everything I wanted to. I don't think there's anything extra that I had to go on about. So I think that's just about it for today. If any of you guys have any questions, please let us know. I know there's comment sections for each one of the platforms that you're on, whether you're on the Facebook group, YouTube channel, or on Vimeo itself. Let us know what you'd like to see in the future, or any questions you might have to help us clarify things for future live events. Don't forget, we have our user forum at forum.bobcad.com, as well as our YouTube channel, which some of you are actually watching on right now, and our Facebook Live group, or Facebook After Dark group, and as well as another Facebook group. I don't know if Al is a moderator on that one as well, but I know he does the After Dark. But that just about does it for today. Until next time, we'll see you again.